Welcome to week 3. Um, Small audience today. Really thought I had a winner coming in. um, but that's okay. So now we're going to start talking about modeling, the diagramming side of it. And of course, there we go. So database modeling is the process of creating diagrams, and there's different levels of complexity. There's 3 common types of diagrams: conceptual, logical, and physical. Um, For the conceptual type, there's 2, traditional and extended. Normally when people talk about um, conceptual diagrams, it's literally, they're just going to say conceptual diagram, and they could mean either. It just depends on what their background is. Logical is the next logical step in creating the database model. I wish that was a pun, but it's not. And then the physical diagram is the final diagram, which that is database engine specific. So conceptual diagrams, they were originally created in 1976. So 1 year after I was born. They've been around for a while. And it was a data scientist whose name was Peter Chen. He's one of the OG, one of the original um, creators of data science. Um, the original version of the conceptual diagram only had entities and relationships. It only used 2 symbols. Entities were a rectangle, relationships were a diamond, and there was a notation on there that described the type of relationship. Whether it was, and they'd use 1, N, and M. And these were written as 1 to 1, 1 to N, M to M. I've also seen NM also used for some unknown reason, but that's a fourth notation that wasn't as common. So when you were describing a relationship, you'd have, for the example here, we have a person and a location, and then we have the birthplace. So a person can only be born in one place, which is where the 1 comes from. Each location can have many people born there. So whatever hospital you were born in as a kid, assuming you were born in a hospital, you can only be born once in that hospital, assuming you were born there, but that hospital probably had a lot of births. That's why it's 1 to N. And then the diagrams evolved. Over the years, the Chen style diagram was given extra symbols. They added attributes because they're like, dude, it's cool that you're telling us how things are related, but it's not telling us, you're not describing them at all. They added new symbols for the entities and the relationships to expand what they were. And they created a different notation style for relationships. Once these were added, the diagrams became known as extended conceptual diagrams. Okay, so attributes on one of these diagrams. Attributes are represented by ovals. However, there are different kinds of attributes, and they're represented by different flavors of these ovals. Go figure. Identifiers are underlined, so these are your primary keys or your unique values, depending on the tool you use. It may say identifier, might say unique key, could be any one of these things. Optional fields will have an O in it. So for fields that, when you are determining whether or not you need it, it may have an O in it saying it's an optional field. Derived attributes are dashed circles. I did describe derived attributes fairly well. An age is a derived attribute because you can calculate it from a person's date of birth. Now minus date of birth tells you how old they are. A composite attribute is enclosed in parentheses. So address right here. The component pieces may or may not be included in the diagram. That one is optional, just depends on where you're working. So sometimes the person will say, well, it's going to be a composite attribute, so they'll just put in address in parentheses, and then the assumption is that people know what makes up an address. And depending what part of the world you're in, those pieces might be slightly different. I mean, there are a few countries where there's no postal codes. Usually tiny little island countries actually have no postal codes. The Fiji Islands don't have postal codes. Why? Because it's just a bunch of small islands and the address says this person lives on this island. The mail just goes to the post office and you just say, I'm Bob, and they give you your mail. Which one? They don't use it because exactly. China has postal codes, and they stopped using them because they were not working for them. That's what I've been told by several Chinese students over the years. So it's kind of cool. So when we're talking about a composite attribute such as the address here, you'll notice it's in parentheses, and in this case, you'll see satellite attributes off of it. These are its component pieces. These pieces are optional if you decide to put them on or not. It might be up to your job. So you could have a boss that says, I want to see the optional attributes. Another one will say, no, I want to know it's composite, and we can worry about it later. So they also said, well, it's nice having known with what are entities, but sometimes there's different versions of entities, and we really should be able to visually identify them. So they added a few. The first one is weak entities. Remember, I spoke about it. Weak entities, such as a payment on a loan. A payment cannot exist without the loan. That is a weak entity. They said, you know what? We should be able to identify when they're weak. And they did it by creating a double box. So instead of just being a square, it's double square. Um, associative entities are identified by diamond in the box. So an associative entity is when you are trying to resolve a many-to-many relationship. At the conceptual stage, it's cool. You don't need to have these unless there is an exception to the rule, which I'll describe in a moment. Um, and the last one is identifying relationship, also modified. When it's identifying, in other words, if it's a relationship that identifies a weak entity, since the weak entity is a double box, the relationship that identifies is the double diamond. Normally, you will not see a weak entity like this without a matching double diamond. If you happen to be using those symbols, not everybody does. Um, this one here, an associative entity, um, normally an associative entity is used to resolve a many-to-many relationship. So, for example, a course and students is often related by a section, right? Because you guys are small enough, you don't have that experience, but the other, like CET and CP, have this problem where, for example, CST8250, the level 1 database course that they have, um, there's 2 lectures. That means there's 2 sections of lecture. So it's the same course, different groups of students, so they create sections in the middle, and that would be an associative entity because it might have extra pieces of information attached to it, right? Could be which prof is teaching that section, what room is it in, that kind of stuff. These would be extra attributes. So the only time you'd have these associative entities would be when just a many-to-many relationship is not enough to describe what you're trying to do. That piece in the middle needs a little more information. So not only does it associate 2 things, it has its own little extra bits of information in it. So a course section has a name. You guys know, you guys are what, 101, 010 is your section for this, if I remember right. But for example, in 8215, they've got section 300 and 310. So the sections have names. That's an extra attribute. There's a lecturer for that section. That's an extra attribute. The room, what time that lecture's at. Those are extra attributes, but that associative entity also maps students to a course. That course has many students, and each student has many courses, and it maps out using sections. Now that we can calculate that from the relationship. Do you remember learning about aggregates last semester? Select, count. You can do that using a join across the associative entity. So you go, you know, select uh, course name, comma, count student.id or whatever from course, join section, join students with all the appropriate things. And then you can tell it to group by the section name or whatever. And then you'd have the total number of students in each section. Get the computer to do the math. Don't do the math yourself. Because you know what humans are really bad at? Math. You know something else humans are really bad at? Rounding. I always say never round yourself. Always use a function to do it. Because somebody else has already figured out how to do it right. Okay. Um, so relationship notation changes. There was something else that happened in regards to this. Um, as things progressed, varying different database notations evolved. A specific type became overwhelmingly popular in North America and basically started becoming adopted elsewhere. It's kind of funny because in data science, different parts of the world were doing their own versions of these notations. And slowly, crow's foot won. Um, why? Because the vast majority of international students back in the day were coming to North America to learn computing, and they were learning crow's foot. Whereas, say in Germany, there might have been only one, two universities teaching computing. In North America, you could go to like 50 different schools. In England, there might have been two. Therefore, as students came here, they learned the notation from here. There is, last time I checked, there's 8 different notations for database relationships. ID1 fix is one. Um, crow's foot's another. The original Chen style is another. There's another one called connect key, which is kind of weird. It uses like a 111 infinity notation to show one to many. So 1:infinity sign to show one to many. And it doesn't know how to do many to many. So there's all these different notations, but well, right now crow's foot is the standard, as in the sense that it's the most popular. Pretty much all diagramming software uses crow's foot. Um, Most people nowadays, when they learn database, even not North America, they're learning with crow's foot notation. There's still a few places like South America, for example, is still really big on ID1 fix. For whatever reason, they just like their notation and they're sticking to it. Um, like I've used a piece of software that was written by a guy in Brazil, and he didn't bring crow's foot for years. He was using the other kind of notation instead. But anyways, it is what it is. But crow's foot's pretty much the de facto standard now. Essentially, it started being created almost at the same time as the Chen diagrams were being created, 1976, but they wasn't adopted till later. But a scientist called Gordon Everest wrote an entire article that basically people read this article, they go, "This makes so much sense," and Crowsfoot was born from that article. So Crowsfoot notation is exceptional because it allows you to do both cardinality and optionality. With most of the other ones, you need two symbols, one to talk about the cardinality and one to talk about whether or not it's the basically they call it minimum and maximum cardinalities. Most other notation systems need two sets of symbols. This only needs one set of symbols. So the cardinality, how many instances participate in a relationship? It's always one or many, right? So essentially we needed to say whether it's only one or more than one that participates. Optionality, what is the minimum number of instances? 0 or 1. So is it optional or not? So if we talk about um, um, trying to come up, I usually have examples right at the tip of my tongue and it's not coming out tonight. Um, okay, a customer in orders. Okay, you could enter a customer into the system. For example, with Amazon, you can register as a customer but not buy anything, right? So the relationship to orders is optional, right? So it's 0. You have 0 orders. It's optional. When it's mandatory, as in when you create an order, you can't create the order unless you have a customer. Therefore, it's mandatory. Therefore, it's 1. So we have 2 sets of flags we got to worry about, right? So what's the maximum number? What's the minimum number? Minimum number means either optional or it's free. The maximum number is 1 or more. So student to locker, 1 to 1. Customer to orders, 1 to many. And here are the symbols. Ignore the box. These are like tables. These are your 4 symbols you need to memorize. That's it. These 4 symbols cover all of it. So 2 lines, one and only one. That's when, for example, you place an order. That order belongs to one customer and only one customer. The order cannot be created unless it has a customer tied to it, and that order can never belong to more than one person. It belongs to, well, that account. Okay? One or more. That's if something is mandatory, but there has to be at least one, but there could be more. So, for example, an example of one or more would be an order with order lines. Imagine you go and you check out and there's nothing in your shopping cart, but you checked out anyways. You created an order with nothing in it. That's technically possible in the database, but realistically, an order must have at least one thing in it. So therefore, when you talk about an order and the items in the order lines, it'll be one or more order lines. You could buy just the one thing, like I need a new memory card for my dash cam. That's one thing in my shopping cart. Or I needed, you know, cat treats. So I bought 3 packages of cat treats. That's 3 things, but it's one or more. 0 or more, that's the customer to orders. Person signs up at Amazon, their account is created, but they have not placed any orders yet. So the orders are optional, but in theory, they could place n number of orders. So that's 0 or more. I've also seen it written as 0, 1 or more, but usually it's just 0 or more because 1 is still more than 0, right? So just saying, technically that's correct. And then 0 or 1. Again, student to locker. A student may have a locker, but they can only ever have one locker. They're not allowed, like here at Algonquin, you're not allowed to rent 2 lockers. If you want to change lockers, you have to go give up and buy a new rent a new locker. Like you literally have to change your subscription to the locker for the semester. So a locker is optional, but you're only ever allowed to have one. So that's what this is down here, this symbol. So yeah, so you just worry about this piece here, like such. And well, here it is explaining it all over again. So this is just a different thing. It explains the exact same thing. I'm not going to go through it in tons of details, but essentially A is related to B and it's 0 or 1. So each B, sorry, each A can have 0 or 1 B. Each B can have one and only, must have one and only one A. Each A must have a B, but could have many B. B can have 0 A or one or more. So a 0 or more A. So when we look at it that way. Okay, so now here's a diagram that shows all the symbols in one place. So literally this is your reference for labs, and this is the slide you really want to study for the exam, for the midterm. Okay, so we already talked about the composite and derived and optional, but here's our relationships here. So shipping methods to order. Each shipping method can be used on no orders or on many orders. Because in theory, you just got a new shipping method and you haven't shipped anything using it yet. Each order has an optional shipping method, which is why it's optional this one, because with Amazon, you place your order, they haven't decided how they're shipping it to you until it's packaged. So it could be coming to you by Amazon Delivery, Intelcom or Dragonfly or whatever they're called now. I've seen Canada Post, I've seen UPS deliver stuff, FedEx. It changes based on whatever. So the shipping method is optional. And then down here we've got the course and the course enrollment. Here's the example I was talking about where student the sections more or less. So a student, the course enrollment's a weak entity because it can't exist without the student or the course. So that's why it's got the weak entity thing here. And these are identifying relationships because this can't exist without these two. So these are all the symbols that we just literally finished talking about. So yeah, so out of all the slides, you read everything, but this is the reference you need for all the rest. And it has another little symbols and arrows on it to explain to you what the pieces are that you need to worry about. Um, so characteristics of a good conceptual diagram. The ideal conceptual model will provide a high-level overview of the system to be built. The point of it is to give you a draft to sketch what the plan is. It's not a formal blueprint yet. It's the overview of what you're planning to do. At this stage, it's much easier to make changes because you're not dealing with the details. Um, it's a blueprint that can be referred throughout the project. Even though it's not detailed, the conceptual diagram helps if somebody new gets onboarded or suddenly a piece of work is going from one developer to another developer. They can use these conceptual diagrams to at least understand what the gross pieces of data are. Um, it avoids technical considerations of terminology. A conceptual diagram should not have anything technical. In other words, you don't worry about data types. You don't worry about the database server it's going to be on. You don't worry about specific terminology. There's specific terminology, yes, but it's not designed, it's not meant to be technical. It's meant to be an overview. It prevents the model from being locked to a particular database system, which makes sense because it's before that happens. You can use it to get feedback from non-technical stakeholders. Because I mean, realistically, as complicated as this diagram looks, if you spend 10 minutes explaining what these symbols mean to a non-technical person, they can look at it and have a pretty good idea of what the data is. And therefore, you can sit there with your manager or their director and go through the plan and give them pictures so they can understand without having tables of data up on a wall. This lets you get the concept across much simpler. And it provides a solid foundation for creating the logical and physical diagrams later. So this is the sketch. If it's well designed and it's survived the whole initial vetting process where everybody agrees that everything is covered, it gives you a good basis to continue from there. So this is the result for last week's example I did at the front of the class. If you remember the books and the authors and all that, we're going to diagram this using the tool you guys are going to use in the lab. So I'm going to be a little clunky in it because they just updated the UI and they changed a lot of things were. Um, it's ERD plus, this guy right here. All right. It's kind of funny because this screen is so low resolution that it looks different on there than it does on my main laptop screen. Here, I'm going to put a new diagram and I'm going to call this lecture 3. As you can see, I've done this before. It's remembering what I typed in the past. And it's going to be an ER diagram, not the relational schema. So ER diagram, go create. And it doesn't bring you right away, it just brings you back to your list of diagrams. Then you go into here. Okay, so it's a diagramming tool. So most of you have probably seen something like draw.io or Visio or a few others out there now that I've seen. Excel Draw or something like that I saw recently. I don't remember that's exactly what it's called, but I just saw somebody at work pulled up a diagram. That's the tool they were using, but it was web-based. Now, the cool thing about ERD Plus is that this tool was created by textbook authors. So these are textbook authors that belong to a university in the US, and I guess they got all their PhD students sit there and write code for them, and they created a diagramming tool. It is the best. Personally, I like the old version better, but the new one does everything the old one did. It's just different layout. It is the best conceptual diagramming tool I've ever used. Visio will do it, but it's clunky. Draw.io or whatever it's called now will do it, but it's clunky. This understands every type of everything. All right, so I'm going to put a label down for starters, and that'll be like what you guys are going to do in the lab. What I did notice though is now they don't let you do multi-line labels. So you have to, if you do more than one line, you have to do more than one label, but that's fine. lecture 3 uh, example. Okay, so that's my diagram. If I want like a second line, I have to put another one on. I don't know why they did that, but it's a little weird. Okay, so here's my my thingy. Okay, so we're going to put it here. All right, so now we're going to go back over like this, and I'm going to put in my entities. So here's one. Now, if I switch back to, there's 1, 2, 3, 4, 5 entities. So I'm going to drop down 5 entities just so that I can just get that over with. Where'd my mouse go? It's over here. 1, 2, 3, 4. All right, here's my entities. When I click on the entity, I can give it names. And I just happen to have the list in front of me, so I'll put them in as I go here. So there's genre, uh, author, book, borrower, and oh, there you go, book, lend. All right. So here's my entities. And you can drag and drop them so you can get them the way you want them to look, whichever way you want. And put the book over here and put that over here. All right. So these are my entities. I am going to add my attributes to it now. So when you click on an entity, you'll see down here it says add attribute. So I'm going to add an attribute. And of course, it popped up way over the top. And this attribute's going to be called borrower ID. And I missed 2 letters. Borrower ID. And I'm going to mark it as unique because that was my primary key. Whoa, whoa, stop. Stop what you're doing. Click. There we go. Web-based tools, they get a little weird sometimes. Okay, so borrower ID. I'm going to then add another attribute. And if I remember right, it's the person's name. Name. All right, so these are my 2 attributes that belong to borrower. It's got its unique ID and its name. Now, if you happen to have some other ones that you need to do, like some of the other fancy ones, they're just checkboxes down the side. So for example, if you want to be composite or optional or derived or multi-valued, which is, 2 circles, they're just flags on here. So you can just turn them on and off as you need. No, the entity has its own things here, which is weak, associative, and supertype. We don't even talk about supertype at all in this course. But regular, weak, and associative, you can set them here, see? By just changing this. And it changes the symbol. It's just because with the attributes, in theory, something could be um, composite and unique kind of thing, right? So that's why these are checkboxes, because you can change multiple flags. All right, let's change, let's do the others now. Author has author ID. Author ID, which is its unique. And I'm going to add name or author name as applicable. Then I'm going to do the same thing here. Uh, genre ID, which is real pain in the butt that I can't see what I'm doing behind my head. And then uh, genre name, because this one here's a little weird. Okay, so here are my attributes on my entities. You got little circles. One of the good things about this tool that Dry.io and Visio doesn't do, you might have just noticed it when I grabbed the author. It moves everything. So it moves not just the entity, moves it with its attributes, and it keeps the attributes in position as you move it around. So it's really good that way because it's able to handle, the relationships for things. Okay. All right, book. This one has a another piece on it. We want to go add book. We want to add an attribute, and it's the book ID, which is unique, and title, like such. Book lend has two more attributes, which is borrow date and return date. Now you'll notice something a little weird after I'm done this diagram compared to the normalization. And I'll explain it in a second after I do the relationships. Whoa. No, no, stop. Stop what you're doing. No, stop that. Okay. All right. So one of the things they did, and um, I'm not a fan of, hang on, I need to, there you go. They changed how the relationships are created in this. It used to have the tool like entity to create relationships. They changed it now, and it's called connect. So you turn on connect mode, and then you click on the entity one, and you drag it to entity two, entity one, to entity two, entity one, to entity two, and here's all our relationships created. So all our diamonds have been put in. It just did it. Um, Now, when you click on the relationship, you can see um, a bunch of different things here. And the cardinalities are set here. So when we say genre, we're talking about how it relates to books. So it's optional many because we could define a genre and not assign it to any books, but a genre could be assigned to many books, right? So you have all the fantasy novels and all the science fiction novels and all the crime novels. Um, in theory, a book can have um, multiple genres, because I've seen that. Um, so what you want to do here is in this drop down, you switch it to book, and you can go mandatory many. So this means that it has to have at least one, but it might have multiple genres. And and then here normally you give the relationship a name of some sort. We're a there like that. You give it a name. Get a notation in here instead. So instead of writing something, they'll go 1 to n. That's another way you could do this. Um, Name should not be empty, of course not. Uh, Book authors, like such. Hey, it's over here. You set it on the cardinality. So each author, um, optional, many. Well, realistically, an author should write a book, otherwise they're not an author. And if we change um, the book has to have an author, but as you guys have seen in your textbooks, a book can have many authors. Okay, so our borrower to relationship, we're going to do the same thing here. The borrower uh, may not even have a book yet. You just went to the library and got your library card, but you haven't checked out any books yet. So the borrower record exists, but they have not borrowed a book yet. So it's optional whether or not they borrow a book. For example, at the Ottawa Public Library, you can get a library membership and never check out a book because you want to use the 3D printers. Because there's 3D printers at the Centerpoint Library. Yeah, you can go and take some courses, and then you use the 3D printers. Like you pay a certain amount for the filament, and you're allowed to just set up print jobs and let them print and then go collect it like later. Kind of cool. And then we flip back with the book lend. Um, when you lend a book, you have to know who borrowed it. Um, and in this case, A borrower can borrow a book, sorry, a given book can be lent to one person at a time, right? Now, you can also use a verb in here. Now, this isn't actually an identifying relationship because the book lend cannot exist. So we can mark that and it becomes an identifying relationship. And now we're going to do the same thing with the book to the lend. This one is optional many because the book, maybe no, it's a brand new book and nobody's borrowed it. And the book lend is mandatory one because each time the book is lent, there's only one copy of the book to be lent. Therefore, it can only be borrowed once per person, essentially. Okay. And again, the book is lent and it's identifying. Now, if I'm going to turn off connect mode now. If this is identifying, this is not a regular entity, it's a weak entity. Because if this one identifies this and this one identifies this, then it's a weak entity. It can't live without its source data. Now, let me flip back to the PowerPoint presentation really quick. Right here. You'll notice here, I've got some foreign keys, a foreign key here. But when you look at the diagram, I don't have the foreign keys. So why do I not have the foreign keys? It's because in a conceptual diagram, you don't put in the foreign keys. That's that's it. You put in the primary keys, and there's an assumption that foreign keys will be brought across. Some people choose to put in the foreign keys. That's fine. But there is no type for foreign key. Therefore, normally you don't put in the foreign keys in the conceptual diagram. So you only worry about the primary keys and the attributes. There's an assumption that when this becomes a physical diagram later, foreign keys will then be created for them as part of the logical diagram process. Okay, so that's why when you look at this, you will notice that it's slightly different than what you would see in the normalization results because we don't have the foreign key. So there's actually more detail in the normalization results than there is in the conceptual diagram for the exact same thing, which is fine. It's all good. All right, so the other thing you need to know for your lab is this button right here. Historically, what happens is people do a big diagram shot, and then I get it and I can't read it because it's tiny. You do download image, and it will give you, if it had opened on the right screen, you would see that it gives you a nice copy of the diagram. When you go to upload the labs for this, that's the piece you need. Now, next week, I'll be doing a demo on the physical diagrams, on how to do them. Because right now, the lab for this week is actually the normalization lab. So next week is the diagramming lab. And there's another kind of diagramming that needs to be learned, which is the physical diagramming. It's in a different tool. You have a choice of a few tools to do this. But make your life easy, just use the web-based tool that I'm going to suggest. One big recommendation is that when you install an ad blocker, the old version didn't have ads. This new one has ads. You can see there's a bar across the bottom here. It says advertisement. I used uBlock Origin as my ad blocker. Realistically, I don't know how anybody surfs the internet without an ad blocker. Because once you do it, you can never go back. Just a pro tip. Just use an ad blocker. Actually, I didn't even realize these even had ads until I had a student come up to me earlier today in another class where they're also using this tool, and they're like, and they show me, and I go, "What is that?" And there's this huge banner ad across the bottom of the screen. I'm like, "What is that?" And I realized, oh, she's not running an ad blocker. So yeah, uBlock Origin, fantastic tool. I'm going to actually add that to the announcement, so you guys have the solution for the lecture to go with it. Um, uBlock Origin, cool thing. It also blocks YouTube ads. So you know how it plays ads at the start or at the end of videos, and sometimes in the middle of videos, it blocks those ads. Oh yes, that'd be defeating the point. They didn't make it free. Then they make it for Edge, for Chrome, for Firefox. And well, Brave just blocks ads by default. So if you use Brave, you don't even have to worry about it because it does it for you. Okay. Um, also, this gives you everything you need to start the next lab. Hang on, where did that go? It disappeared on me. Hold on. There we go. I'm just going to move this screen so I don't have to crane my neck around. I'm just going to find the lab, because you guys are starting lab 3, the normalization lab, this week or last week, depending on how ahead of time you decide to be. Um, labs. Uh, so this lab is really long. It looks long because it's just long to read. It's not long to do. Okay. So lab 4, right? Not due till middle of February. We're still in January, just so you know. Normally, I actually have to cover some of the physical diagramming now, but because of how the semester worked out, timing wise, it ends up giving us more time. Um, so you're going to create 2 conceptual diagrams, ERD plus, and then there's 2 physical diagrams also. Oh, I got to change this URL. Shoot, they changed that. I'll fix this. It's not called Vertibello anymore. It's called Redgate. They got bought out like in the fall, because last summer it was still called Vertibello, so they changed names. And this also has 2 diagrams. That's roughly what the diagrams are going to look like. But you should be able to do part 1, which is the conceptuals after today. Um, so how it works is there's 2 scenarios that explains all the data and the relationships, and it gives you the entities. The stuff that's bolded is the identifiers. And then scenario 2, same deal. So you've got to do 2 conceptual diagrams, 1 for each scenario, and 2 physical diagrams, 1 for each scenario. Which is why this is kind of like, it's good that you've got like 2 weeks between them, because you could start on one, take a break, and then do the other. But yeah, that's the lab for this week. It's not a super hard lab. Getting used to the piece of software is actually as much of the challenge as the actual work. But conceptual diagramming is a very straightforward concept compared to some of the other stuff. Okay,